one piece down, and many more to go. But in this video, we will tackle one more, and we'll take care of it before we go any further. So previously, we talked about the mobile phase holder. This is the tray that sits on top that holds the mobile phase jugs that are filled with eluent, or the mobile phases like methanol and water and the buffers that the machine requires in order to push your sample through it. And we talked about the importance of the right quality. So a lot of times we're looking for HPLC grade quality, which is a little bit more expensive than the traditional lab grade that you might order or that your teacher might order for a laboratory. Okay, so what is next up on the list? So if we go back to the instrument, we've talked about this tray and the purpose of the mobile phases up here at the top, with each one of these lines labeled as A, B, C, or D, so the machine understands which one's which. And now we need to migrate down to the next box. So that's this tray here. So what is that box called and what does it do? Okay, well, this box is called a degasser. So we need to talk about the purpose of the degasser. Why do we even have a degasser in the first place? And what does it do and how does it do its job and why is it so important? All right, so let's start off talking about the purpose of the degasser. Well, this name kind of says it all. I don't think that this is rocket science here, right? So degas basically means to remove the gases from something, right? That's the purpose of it. That's what it does. A degasser removes gases. So the word de just really represents removes, to take away. Okay, so what is it really removing? And why is it so important? Okay, so up on top, these are the mobile phase jugs. Mobile phase I'm going to abbreviate as MPH, mobile phase. And these mobile phase jugs have some liquid in them. All right, so once again, imagine you going to the grocery store, and imagine you going up to buy a 2-liter of soda, and you go home, and you unscrew the cap on the soda, and you're going to hear that beautiful psst noise, right? That lets you know that this is fresh. Well, what they do is that in the manufacturing process, that gas is carbon dioxide. They carbonate the drink. And that gas is trapped in that container in a closed seal, which is what we call the lid, to prevent the gas from escaping. Because you want that sudsy, bubbly kind of feeling. It makes you happy. Well, if we leave that soda with the cap open out on the kitchen counter and we come back maybe a day later, well, you're going to take a swig of the Coke and you're going to go, this thing is flat. Well, what does that mean? Flat, right? So in the soda world, flat is bad. But in the HPLC world, flat is good. You always love my little smiley faces, don't you? Can't you tell I was an artist? Okay, so when we use the mobile phases, we pour the mobile phase into the jug. And inside of this jug, we have trapped gases. Now, it's nothing like a 2-liter of soda, right? I mean, this is water, and I've poured water into the container. And if I look at that container, it's not going to be sudsy and bubbly and fizzy on me, right? It's just water. But believe it or not, there is still trace amounts of gases that are on the inside. And I want to remove the trace amount of gases that's on the mobile phases or in the jugs. And I have to do that to each one. If I don't do that to each one, then these gases are going to cause me a problem. And that problem is air bubbles again. So these gases will create air pockets or air bubbles, and bubbles are bad. And I need to get rid of all of the gases so that way these air bubbles do not stay behind. And that is the purpose of the degasser. So believe it or not, when you take a look at something like a normal jug of water that we have poured from maybe the faucet, even though you do not see bubbles floating around in there, or a lot of them floating around in there, we need to remove them before they go into the instrument. And that's the purpose of the degasser, and that's what the degasser does. So if I go back to the instrument, again, that is that box there that sits right underneath the mobile phase tray. So the liquids get pulled up from the tubing, and the tubing, if you look, goes directly into the degasser, and the degasser begins to degas the samples. So here's a closer look. So mobile phase jugs with mobile phase in them. The tubing comes out. It kind of circles in back and around and into the DGU unit. D for DE, G for gas, and U for unit. See, Shimatsu didn't make this difficult for you. So degasser unit. That is the purpose of that small, slender box right there. So again, we want to prevent air from getting into the machine. The degasser gets rid of the air because air can be trapped on the inside, and air is bad for separation. Now, how does it do its job, right? Okay, so imagine that this is the piece of tubing that goes into the degasser. And this tubing has some liquid in it. Okay, so what I'm going to do is I'm going to erase this line because this tubing is very narrow, and I'm just going to make it a little wider so that way we can kind of attempt to draw what's going on here. So I'm going to make this a little wider. We're going to zoom in on the piece of tubing. So here it is. Alright, so in this way I get mobile phase, and I'm just going to kind of draw some lines that show the mobile phase going through the tubing. And this mobile phase has some air bubbles. There might not be very many, but they're in there. And we want to get rid of them, whether it's in the water, they're there. Methanol, it's there. Acetonitrile, guess what? Air bubbles are there. Buffers, you got it. Air bubbles are going to be there. We need to remove the air bubbles from all the mobile phases when we use them. Okay, well, the lining of this tubing is very porous. Not porous enough to allow liquid to escape, but porous enough to allow gases to escape. So these are extremely small openings. Imagine a sponge. And this sponge will allow things to cross the membrane. Well, the holes of the sponge are going to be so tiny that liquid will not be able to escape ever. But they're big enough to allow very small gas molecules to escape through. Okay, well, sometimes this happens very naturally, right? Gases love to diffuse, and the process of diffusion you might have learned about already. So every now and then one of these gas molecules will probably just leave on its own. Okay, but we can't rely on the gas molecules to relieve or release on their own. We've got to kind of promote it to do its job. So that's the purpose of the degasser. So what happens with the degasser is that we have vibrations. We make this mobile phase work out. In the name of Richard Simmons, we're going to do some workouts. Okay, so the mobile phases come through this tubing, and they are hit with very high frequency, fast vibrations. We jiggle. And jiggling allows these gas molecules to escape out of the piece of tubing a little bit better and a little bit quicker. So jiggle is good. Beyonce told you that. You should have listened. You weren't ready for her jelly. That was the song she had, wasn't it? Okay, so jiggle is good. So we're jiggling these mobile phases. When we jiggle the mobile phases, the gas particles begin to leave, and then we degas the sample. We make it go flat. And then out of the other end of the column, what we see is that there's no more gas particles that are left behind. All of the gas bubbles have been disposed of. They've been diffused out of the liquids itself, and the pure liquid then goes into the instrument. Okay. Well, before this technology existed, there were multiple ways to jiggle bubbles out of solution. And this had to be done by hand. So again, instrumentation's made our life much easier. We used to have to go into a lab like those poor people did back in the early 1900s, and we used to have to degas the sample ourselves. So again, imagine those poor scientists sitting on the lab bench staring at a column all day long. There were people that just had to make things go flat all day long. Okay, well, how did we do that? Well, first off, we have to use heat, low amounts, and we have to be able to stir things. Stirring and heat makes things degas a little bit better. So imagine for a minute Coca-Cola. You put it in the refrigerator. Why? Low temperatures increase the solubility of gases. So you keep it in the fridge to keep it cold. Keeping it cold allows the gas to stay in solution longer because they're more soluble in a cold environment. You put the Coke in a car, and if you've already popped the cap on it, the heat from a hot summer day can shine down on that Coca-Cola bottle, and it increases the temperature of the solution, and gases are not soluble in hot temperatures. So the gases begin to diffuse up and out of the jug. Well, we play off of that. We play around with this heat and this stirring that happens with our mobile phases. So there's some alternatives. If you do not have a degasser, what can you do? Well, number one is that you can set your mobile phase jug down into a container full of warm water. Now notice it doesn't say boiling water, right? It says warm water. And it actually goes through and it says slightly hotter than room temperature, not by much. 5 degrees, right? A little bit of warmth, but something that you can put your finger in and leave it there all day long. We're making a nice little sauna for the mobile phases. And then we loosen the cap up a little bit up here at the top. We don't want air to be trapped on the inside, so we keep the cap of it on there. But we want to loosen it so that way gases can begin to get expelled out of the jug. All right, well, that's one way. This thing took hours. You would start it in the morning. By lunchtime, it would be done. If you're unlucky, by the end of the day, it will be done. But this is one way that we used to do degassing mobile phases over and over and over all day long when we needed them. Okay, well, option number 2 was to pull out the gases a little bit quicker. So this is still a mobile phase jug, and there's still liquid on the inside, and there's gas that we've got to remove. So what happens is that we hook it up to an aspirator. So this is from your faucet, and this is what we call an aspirator. So water will be turned on up here at the spigot, and water will flow through this tubing and through the aspirator and down into the sink. And that flow of water creates some pressure. It creates some sucking, just like you sucking up from a straw, right? So this sucking power that begins to happen begins to suck out the gases that are inside of this mobile phase. Now, notice there's not any tubing that goes into the liquid. We are sucking the headspace the gas above the liquid out, slowly but surely. It works a little bit quicker, and there's no heat involved most of the time. So instead of lunchtime, you might be done in about 2 hours. Okay, well, that got better, but it still was a pain. Nobody wants to degas mobile phases by hand. And then option number 3 was to say, okay, well, here's another way that you could do it. Let's put the mobile phase jug down into another sauna, and this is going to have a magnet on the inside, and we put a little bit of heat on it, not much. So one of these knobs would control the heat. One of these knobs would control that magnet on the inside, and we would slowly stir it, and we would gradually keep it warm, and those gases would eventually leave out of the jug. Now notice that this does not have a lid. This has a big piece of glassware up on the top called a condenser, or a reflux condenser. And what was happening is that things like methanol evaporate off quite easily. And because I don't have a lid, methanol would just evaporate right out of the jug. So what we do is that we put a refluxer on it. So that way, if methanol does start to evaporate off, it goes into this condenser, and it does just that. It condenses it back down to a liquid. Okay? So methanol begins to evaporate off. Well, the gases would keep going out, hopefully, and the methanol would just be condensed back down to a liquid, and it would drip back down into the container or the mobile phase jug. And the reason that this condensed in the condenser or the reflux tube is because there's going to be cold water. Cold water goes in from the bottom and it leaves out of the top. So this stays cold the entire time. So gases, of course, would just keep dissipating out, but any kind of solvent that begins to evaporate on me would be condensed back down to a liquid before it had a chance to leave, and I could recapture that into the mobile phase jug down below. So these were 3 options that we had to do with degassing mobile phases, and no longer do we have to do that. Now we've got a nice piece of equipment that will do it for us. Now there's different forms of degassers that are out there, but jiggling with this ultrasonic vibration is the most common and the cheapest. So again, that's all that we're going to focus on. The most common pieces, and typically what you would see in a working environment. And this is the ultrasonic degasser. It vibrates, it jiggles, the bubbles leave, and it does its job. Much better than hours on end of mobile phase prep. So, we've now finished talking about the degasser. Thank goodness that the degasser's there for me. And in the next video, we'll move on to our next part, and the next piece that we talk about will be our pump.